This is Book D2, Question 12, Exercise 1B. Exercise 1B, Book D2, Question number 12. The braking distance of a vehicle is directly proportional to the square of its speed. When the speed of the vehicle is b meters per second, its braking distance is dm. If the speed of the vehicle is increased by 200%, find the percentage increase in its braking distance. We know that the braking distance of a vehicle means that the distance when we apply the brake, the time and the distance which requires to stop the vehicle is called, that distance is called the braking distance, and that is directly proportional to the square of its speed. Its relationship is direct with its speed. Since the speed is higher, the braking distance will be definitely more, and if the speed is lower, then the braking distance is low. So they have given us when the speed of the vehicle is b meters per second and the braking distance is given as d meter. These are the values. So first we will assume that the variables, these are considered to be the values. B meters per second is the speed value and d meter is the value for the distance. So let's assume that the braking distance, so we will suppose that let the braking distance, it's up to us, whatever variable we want to use we can use. So I can use the braking distance for the same, like just like dm is the value, so I'm using the capital D for the variable, and that would be dm. And let the speed of the vehicle will be, speed of vehicle is equals to, since the speed is given as small b meters per second, this is the value, so I am using the variable that is b meters per second. For this I will be comparing the values and then I'm using these variables with the help of the values. I know that the direct relationship has been given as well, that since d is directly proportional to b square. This has been given in the question as the braking distance of the vehicle is directly proportional to the square of its speed. So I'm using that d is directly proportional to the square of the speed, since the speed has been taken with the variable b and d has been taken as the variable for the distance. So I will be making a relationship, and that will be d is directly proportional to b square. Whenever we are removing this proportionality sign, we write d is equals to kb square. So this is an expression which we have made with the help of the statement, the braking distance of the vehicle is directly proportional to the square of its speed. Now we all know that k is a constant, and first whenever we are taking any equation connecting two variables, we always find the value of k. So first we need to calculate the value of k. The values will be put, the values are given as b meters per second and d meters. So I am using the same, just like the previous questions of exercise 1a and 1b of direct and inverse proportion, where we are using the equation connecting direct proportion and inverse proportion. The first step is always to find the value of k. So I'm going to find the value of k. I know that b and d is given as d is equals to d meters and b is given as b meters per second. So I'm putting this value over here. So I'll get d, I'm replacing this d with d because now this variable has a value d. So I'm putting d is equal to now k, and this b is actually b square. So after this, we know that we find the value of k by taking this k to the side, and b square will be shifted to the other side and it will become d by b square. Now this value of k, just like the previous questions, whenever we are taking the equation connecting two variables of direct or inverse proportion, we first find the value of k. So I just found the value of k. Now I'm putting the value of k again back to the expression just like the previous question. So I'm putting this value of k in this expression and it will become d is equals to, the k is d by b square, and over here we had this expression which we have already made with the help of this statement. So I have put this value over here. I know that this expression just we have made is just because I have gotten this expression, so I just put. But there is, again, I that there is no such value to calculate, so I'm stopping it here and I'm making it an equation number 1. I'm just writing it that this is an equation number 1. Now we know that the speed is again not given, but the percentage increase is given as 200%. So again, we assume that the speed is actually 100%. Now we are assuming that this is 100%. So if we are increasing, if we increase it to 200%, definitely the increase means that we are adding this percentage to the original value. So we will write this B, which is already actually B. Over here we wrote that B is B meters, so I'm writing B is actually, the value was already B. So if I am increasing, definitely this increase means that we talk about the increase. So we will write B is equals to, originally it was 100% and I am increasing it to 200%. So the value is now no more B is, the value is 100% plus 200%, because the value has been increased to completely in the percentage of it. Obviously we are going to calculate, and it is equals to, obviously when we add these two we get 300% into B. Again, we already know that the percentage sign means that we always divide it by the 100. So I am removing this percentage sign and I will be writing B is equals to 300 over 100B. When we divide it, or either we can directly cancel it, it's up to us. Whatever way we do it, we will get, in this way we will get B, the value of B is equals to 3B. I hope this expression, now after increasing, the value is no more B, the value is 3B. Okay. After this, again moving back to this expression number, this one, we will be using this B is 3B now. So I'm putting this value over here and I will get D is equals to D over B square, but only this B will be 3B, and since it was B square, so I'm writing 3B square. Now D is equals to D by B square, and this will be 9B square. Now B square will be cancelled with B square and I will get D is equals to 9D. Now over here I have gotten the value of D is 90 after the increased percentage, and after the increased percentage B is 3B. Now the values has been changed to 3B and 90. Okay. Now the point is to take the percentage increase. Now moving on to the question statement that we had to find the percentage increase. We know that the percentage increase is equals to whichever quantity it is. For example, since we are calculating the percentage increase of the distance, braking distance, so we will write new distance minus old distance and this has to be divided by old distance, since the value is now distance, so we are using it, multiply by 100%. Now after this, new distance minus old distance. So let's see that what is new distance. We have found that the new distance is 90 after the percentage increase, and the old distance was only D. Over the old distance is again D into 100%. So the percentage increase would be 90 minus D means 8D by D into 100%. So later on we will just cancel out and we will get 8 into 100%, and this is equals to 800%. So finally we get the percentage increase. Just we talk about over here, we talk about that the percentage increase in the braking distance is 800%. This is what we have found. I'm just repeating my whole question again. That first what we did, we first found let the braking distance is dm and the speed of the vehicle is b. This is my own suggested variables. Then I created an expression d is directly proportional to b square with the help of the statement that it is proportional to the square of its speed. After this I used the expression by putting the proportionality sign. Instead of proportionality sign we put equals to and k is a constant. Then we put the values to find the value of k. As always, we do the expression. Whenever there is an expression, we always put the value. So I put the value d is equals to d, b is equals to b. From here, I got the value of k, which is k by b square. And when I put back again, because the values were put into the equation, general equation of direct proportion, so over here I get d is equals to over only the value of k, which is d by b square. Now the speed has been increased 100. Already it was 100%, so when we are increasing it, it becomes b is actually b. Previously b was b, we wrote b is equals to b. Now b is 100 plus 200b, so it's b is equals to 300%. And then I just remove the percentage sign, I get 300 by 100, and when I cancel it out, I got the new value of b is 3b, and the new value of d also, by putting it back again in this expression, I get d is equals to d by b 3b square, where b, I use this value of b in this expression, so I get 9b square, and b square is cancelled, so I get the new value of d as 90. Now after this, I found the percentage increase is the new distance minus old distance into 100% divided by old distance. So the new values I just subtracted and then cancel out, and I get the percentage increase in the breaking distance is this. I hope this question number 12 is clear, and you will be using the same concept in other questions to find the percentage increase as well.